Breadboard is where your prototype gadgets will start their life and where you will be experimenting with various configurations of your circuitry. Unless your circuit is very small and it can fit directly onto the headers of the Arduino or perhaps on a prototyping shield that plugs onto the Arduino, and I'm going to show you an example a bit later, then your circuits will be assembled on a breadboard like this. Breadboards come in different sizes and configurations, and I've got three examples here. So you see the larger one in the middle, which gives you two separate prototyping areas plus connectors for power, so you can have two different voltages, for example 5 volts and 3.3 volts, plus another connector for the ground. But in most cases, especially when you are starting, you will be using either a small breadboard like this one or a mini breadboard like this green or yellow breadboard. Regardless of which size of breadboard you decide to start using, they are all operating under the same principles, so your skills can be transferred from a mini tiny breadboard to a gigantic one. There really is no difference in the way that they operate. Let's have a quick look at what happens inside a breadboard before I show you a few other bits of information that I think are important to have. So I'll turn the breadboard upside down, and I have removed the adhesive backing of this breadboard, and you can see that there are metal connectors that electrically allow a connection to take place for anything that is plugged in a vertical column. So I'm going to use a screwdriver to try and pry out one of those metal rods to see what's inside. So I'm going to push it, I'm going to push it from the front, and you can see the metal bit coming out. So I'm going to lift it like that. And you can see what the connector looks like on the inside. Take a jumper wire and plug it in, and this is how you have a connection. So you can see now, since I've got a metal conductor, that whatever this black wire is connected to, the signal will propagate across the connector to any of the other pins. So if I connect my jumper wire to any of the pins on any of the vertical connectors, then any other wire connected to the same column will be at the same voltage differential. So essentially, the black wire and the red wire are connected together. If I connect the red wire to any of the other vertical columns, then I don't have a connection now. I don't have an electrical connection between the black and the red wire, because the metal rods that make these connections possible are not connected to each other. They are isolated. Now, if I wanted to actually connect the two wires together, even though they are in different columns, then I would need to use another wire. Let's say take a green wire and connect the two columns together like this. So now all my three jumper wires are electrically connected via the green wire, which is acting as a bridge between the two vertical columns. So I'll put the metal connector back in its place and have a look at the larger breadboard. So this breadboard again has the exact same configuration inside. If I remove the adhesive backing, you'll be able to see it. But now this one, in addition to the series of vertical connectors that allow you to connect together any jumper wire or any component on a single column, there's another two longer connectors that allow you to create what's called a power column, actually two power columns, one for positive voltages and one for negative voltages. So if there are components like transistors or LEDs, for example, that need to draw power in order for them to do something useful, then using a breadboard like this, you can conveniently apply power to these two columns. You can see that they're all connected horizontally this time, and then you can draw power from these columns directly. So for example, let's say that I have this device connected to my breadboard. This is an ultrasonic distance sensor, and I've got a whole lecture explaining to you how to operate one of these sensors. So let's say that I plug it just like that here. You can notice that there is a ground pin and a VCC pin. Ground pin means 0 differential, and VCC pin means 5 volts for this particular sensor. So I can plug in my 5 volts power to this device and then use jumper wires to connect this power to my connected device like that. So that's 5 volts, and there is my ground connected like that. Now, since I am on the topic of a breadboard, I've got a lecture on power later, but I think it's a good opportunity to also show you a convenient way to provide power to a breadboard just like this, of this particular type and shape. And it's this device here. It's called a breadboard power supply. So it's got pins that are at just the right dimension to plug into the two power rails, the top and the bottom power rail of my breadboard. So I can connect them like this. And now you can see that the negative pin of the breadboard power supply provides power to the blue power rail, and then the positive pin provides power to the red power rail. And the same thing happens across the other side. Minus for ground, plus for 5 or 3 volts positive. The other nice thing about this particular power supply is you can select the voltage that you want to pass across the power rails. So you have a choice of 5 volts or 3.3 volts voltage. So you can use this jumper switch to engage one or the other. So if I wanted a 5 volt power supply on my power rail, then I will use my jumper to connect the two leftmost pins and therefore enable the 5 volt power supply. And if I wanted 3.3 volts, then I would connect the two rightmost pins together. And because I've got two of those, I can actually have a 3.3 volt power supply on one side and a 5 volt power supply on the other side, just by manipulating the jumpers here. And the last thing about this power supply is that it gives me the option of providing input power either via a barrel connector or via USB through a USB power supply. So a power connector will be something like this. An old unused power supply from an old electronic device could very well serve as a power supply for your Arduino projects. You plug it in there, press a switch on, and you've got power for your breadboard. So it's very convenient. Now, if your circuits start growing in size, obviously a mini breadboard eventually will not be enough. So what you do then is to go for a larger size breadboard. So with a breadboard like that, you have several times the real estate of your mini breadboard. You can see it can fit twice, two independent breadboard supplies. We've got 4 times the size of the mini breadboard. You get the exact same characteristics, so you still get your two power columns per breadboard segment, so in total 4 power columns, and of course vertically the vertical columns behave in the exact same way in terms of electrical connectivity. What you get in addition on a breadboard like this is that you've got your power connectors on the side. So I've twisted it too hard. How did I do that? Anyway, so with these connectors you can get power from an external power supply and then hook it into the power rails of your breadboard. If I lift this in this way, you can see that there is a little hole here through which you can pass wires. These could be, for example, a jumper wire like this. You can secure it by twisting it, and then from there you can plug it into your power rail like this, and you can do the same thing with the ground. So I'll just really quickly show you. Like that. And then you can connect your external power supply to your connectors like that. Now you got whatever voltage your power supply provides onto the breadboard power rail with a lot more space for your circuits. So to recap, having lots of little breadboards like these or mini breadboards like these is a good idea. These are very inexpensive little devices, and it's always good to have several of them lying around. Once your projects grow, then I recommend that you go for a larger, at least one larger breadboard like this one, just to allow you more space for your connection so you don't run out of space as your gadget is growing.